Alright, today we're going to learn how to calculate empirical formula, but first we need to talk about the definition of empirical formula. So, the definition of empirical formula is the reduced formula of a molecule. Sometimes empirical formulas are equal to molecular formulas. You can go ahead and pause this at any point in time to catch up. The next thing we're going to do is I'm going to show you the molecular formula, and I'm have you convert it into the empirical formula. So our first molecular formula is C13O26H13. The way we convert this to the empirical formula is by dividing by the number that will go into all three of those, the largest number that will go into all three of those. So it looks to me like 13 will go into all three of those. So when we divide every subscript by 13, we get CO2H. This is the molecular formula. This is its empirical formula. Next example will be P6O18. It looks to me like 6 will go into 6 and 18. If we divide both of these by 6, we will get PO3. Molecular formula, empirical formula. One last example. That example happens to be on there twice, so don't worry about this one. The next one we have is Ca2O. We only have one oxygen and two calciums. So because we can't take anything out of this besides one, our molecular formula is the same as our empirical formula. Alright, next up we're going to learn how to calculate empirical formula. These are the directions for calculating empirical formula. You can take a few minutes to write them down. Go ahead and pause this video, and then we'll work through a couple problems. This chant is to help you go from mass or percentage all the way out to ratio. So it's mass, mole, ratio. What that means is you need to convert to grams, either by changing percentage to grams or by subtracting from a total. Then you go from grams to moles by dividing by the molar mass. And then you go to a ratio by dividing by the smallest mole value. And we'll go through several examples. So go ahead and pause this and get down those directions. Alright, so we are going to calculate the empirical formula for a compound that has 32% sodium, 23% sulfur, and 45% oxygen. Remember, you can pause at any time to catch up. So the first step is to create a table. So we're going to create a table that has 3 columns, one for mass, one for moles, and one for ratio. Again, that chant, mass, mole, ratio. And then, because we have sodium, sulfur, and oxygen, we're going to have 3 rows. One for sodium, one for sulfur, and one for oxygen. We have 32% sodium. We can change that right into 32 grams. 23% sulfur. We can change that to 23 grams. And 45% oxygen. We can change that to 45 grams. Okay, once we have mass, we need to convert to moles. The way you convert to moles is by dividing by the molar mass of that compound. So if you look at sodium on the periodic table, its molar mass is 22.98 grams per mole. So you can just call that 23. So we're going to divide 32 by 23 grams and get a mole value. Again, that's the weight on the periodic table. Sulfur weighs 32.0 grams per mole. So we're going to leave that 32. And oxygen weighs 15.999, so we're just going to call that 16. So those weights came from the periodic table. Then we're going to calculate the mole values. 32 divided by 23 is 1.4. 23 divided by 32 is 0.7. And 45 divided by 16 is 2.8. Okay, so now we have our moles. Last thing we need to do is calculate the ratio. So we find the smallest mole value. So 0.7 is smaller than 1.4, and it's smaller than 2.8. So 0.7 is our smallest value in the moles area. So we divide everything by 0.7. So again, you divide by the smallest mole value. Now when we do that division, 1.4 divided by 7 is 2, 0.7 divided by 0.7 is 1, and 2.8 divided by 0.7 is 4. So what we have here are the subscripts for our empirical formula. So sodium subscript will be 2, so we have Na2. Sulfur subscript will be 1, so we have just S. And oxygen subscript will be 4, so we have O4. So our compound is sodium sulfate, Na2SO4. We're going to do one more example where the ratios don't turn out quite as nice and you have to multiply by a number in order to even them out. So here we are. So example of empirical formula that is not even. If the ratio is not a whole number, then multiply everything by a factor that will make it a whole number. So our example problem is a 10.1 gram sample of a compound has phosphorus and oxygen. There is 4.4 grams of phosphorus. What is the empirical formula? So again, 3 columns, mass, mole, ratio. And then we just need 2 rows, one for phosphorus, one for oxygen. And we're told the mass of phosphorus, 4.4 grams. We don't know the mass of oxygen, but we can find it easily enough. If our total compound weighs 10.1 grams, and we subtract 4.4 from it, that'll be the mass of our oxygen. So 10.1 minus 4.4 is 5.7 grams. Now that we have masses, we need to convert to moles, so we divide by the molar mass. Phosphorus weighs 31 grams per mole, so that's 0.14 moles. And oxygen weighs 16 grams per mole, so that's 0.35 moles. Now we have our moles and we need our ratio. The way we get our ratio is by dividing by the smallest mole value. So 0.14 is smaller than 0.35, so we divide both by 0.14. 0.14 divided by 0.14 is 1. 0.35 divided by 0.14 is 2.5, however. So what this gives us initially is phosphorus with a subscript of 1 and oxygen with a subscript of 2.5. But that doesn't work out very nicely. So the number we can multiply both of those by to get whole numbers is 2. If we multiply everything by 2, we get P2O5 for a final answer. Rewatch this video if you need to. Come in and ask questions if you have any. I'm available before school, at lunch, or during seminar.